Hey everyone, welcome to our lesson on multiplying and dividing rational expressions. Rational expressions are going to be those typically that have fractions, and we may have a lot of multiplication to do because we may have two or more groups of expressions. Your strategy for multiplying these is going to be to always look in the beginning to see if there's anything that can factor out or cancel out in the numerator and the denominator. And then you're going to proceed to multiply the numerators together, top times top, and multiply the denominators. Any of the things on the bottom go together. And then at the end, you want to go back and simplify again, looking for things to cancel, because we always want to end on the most simplified form of our answer. So let's take a look at an example of multiplication. So remember, our first step is to scan through and see if there's anything that can cancel. In this form here, I don't see any, but if I factor out any common things from each expression, then I may see some things at that point that can cancel. So let's do that first. So factoring the numerators and denominators. On the left numerator, there's nothing that I can do there. It's just a 5x, so I'll leave it. On the bottom, I can factor that expression into x plus 2 times x minus 1. If you're not sure about the factoring, you can multiply out your factors again and you should reach the original expression. So if I multiplied x plus 2 times x minus 1 just to check myself, I should get back to x squared plus x minus 2. Okay? On the second fraction here, it looks like they share a common factor of 4, so I could take that out in the front and see what I have left. I've got x minus 1. And again, if you wanted to multiply this back out by distributing to check to see that you come up with your original numerator, that would be a good idea. And on the bottom, looks like they share an x. I can take one of those away, and I'm left with x plus 3. Okay, so this is just all one big product now. So I'm going to scan through, and anything that is the same expression or term on the top and the bottom, I can cancel those out. So let's do that over here. So we've got our example. We've got everything factored out. This is just what we've done. And I see an x minus 1 in the numerator and denominator that can go away. And I also see an x. One each on top and bottom, so those can go away. Nothing else is matching here, so I think I'm going to have to leave everything else where it is. So now we're ready to multiply the numerators and the denominators separately. So doing that up top, I've got 5 times 4, which gives me 20. And then on the bottom, I'm going to have to do a little bit of FOIL. It's a method of multiplying two binomials, first terms, then outer terms, then inner, and then last. So I've got these two here. I'm going to do the first terms, which gives me x squared. The outer, which gives me 3x. The inner terms on those expressions gives me 2x. And the last two gives me 6. And I can see on the denominator there's a couple of things that are like terms that can go together. So we'll add those up and we'll have 5x. Okay, so let's go ahead and finish that one out. Here, x squared plus 5x plus 6. All right, and we're finished with our multiplication example. The next thing we want to take a look at is dividing rational expressions. And it's basically going to be the same process that you just saw with multiplication. But first, you want to take your division symbol and change it to multiplication. And you're going to take the reciprocal of the second fraction. So instead of dividing, you're actually going to be multiplying by the reciprocal of the second thing that you see. After that point, it's the same steps. So here we have our division example for rational expressions. And remember, we just mentioned that the very first step for these is going to be to change that symbol in the middle to multiplication and multiply by the reciprocal of the second term. So I'm going to do that first thing. We're going to change this to multiplication and flip this second term. All right, so now we're ready to go. We're just going to follow the same process as our multiplication problem. Scan through and see if anything can be factored. So it looks like this first numerator could be factored into x minus 3 times x plus 1. And again, if you're not sure about your factoring, just FOIL it back out and make sure you get to the original expression. Over x plus 5, nothing can be done there. Multiplied by 4x, nothing can be done there. But in the denominator here, I can factor this to be x plus 3 times x minus 3. Alright, so we're going to scan through and see if anything matches top to bottom, and I do see one thing, one expression, and therefore we can cancel that. And now what we want to do from here is write all of our factors together on the numerator and denominator. So putting them all together, because it's just all one big product now, we will have x plus 1 times 4x over x plus 5 times x plus 3. Now this is our answer in factor form. Okay, so it's perfectly acceptable to leave it in that form. If you wanted to, however, you can go ahead and continue and multiply out the numerators and the denominators and leave it in that form. So I'll show you that here. To multiply your numerator here, you just want to distribute the 4x. So we'll have 4x squared plus 4x over, we're going to FOIL this denominator, so we're going to have x times x, x times 3, x times 5, that gives me 5x and another 3x, which is 8x. And then 5 times 3 gives me 15. And so this is the multiplied form of our answer. So you can write it in either of these forms as long as it's simplified all the way. So this concludes our lesson on multiplying and dividing rational expressions.